So in this video, 3.13, we're going to be talking about composition of trig and inverse functions. So composition is something we've actually already talked about in this unit, and I want to start with a review example so that it makes a little bit more sense later. If I'm finding a composition like f of g of -2, we always tended to focus on the most interior function first. So if we plugged -2 into the g function, or g of -2 equals -2 squared plus 5, if we did the order of operations, squared this and got 4 plus 5, we would get, when we plug in -2 into the g function, the output value was 9. Are we done with this composition? Well, no, because now we know that g of -2 is actually the output value of 9, but we are still finding f of 9. So that means that I'm going to plug 9 into my f function, which would be 3 times 9 minus 2, or 27 minus 2, or 25. So what a composition function really means is you start with the most interior function and then work your way out. This logic will help us with the composition of trig and inverse trig functions. So notice I have a unit circle here again, because this video, the practice problems all can be done on the unit circle. However, the next video, they all cannot be done on the unit circle because the angles are not on the unit circle. Before we get to composition, we have a couple just review examples. Evaluate the exact value in radians of the arc sine of -√3/2. Now, whenever you see arc sine, arc cosine, arc tangent, please remember that you have to check restrictions at the beginning. So I want to just double check if I take -√3 and then divide that by 2, this is really -0.866, which is in the restrictions for the domain, so I know I can continue we're just being safe. Arc sine, we're given the ratio. We're asking where is the y value, what angles are the y value, -√3/2. This is similar to the last video. It is true here and also here. So there are two possible answers, but arc sine is restricted between -π/2 and π/2, or in quadrants, again, 1 and 4. So the angle that makes sense is 5π/3. However, 5π/3 is not between -π/2 and π/2. So just like the last video, if you think about it as that is the first over 3 angle that we get to, we can think of this as really -π/3, which is within our restrictions. So again, we plugged in a ratio, got out an angle. This example, we're dealing with the sine function, not arc sine. So sine has no restrictions. But what could be useful is either noticing that if you're talking about -π/3, you are going negative 1 time, so you are really landing at 5π/3. You can think of that as kind of a coterminal idea. So what is the y value at -π/3? Well, -√3/2. There is a reason, there is a connection between these two, and it is somewhat going to be shown now. Again, your circle plate might be nice to have out because I'm sure the colorful nature of it might help some of you. So just like the previous review example, composition of functions means that we work inside out. So the first thing we want to consider is the arc sine. Now remember, arc sine has restrictions, so we need to think about quadrants 1 and 4. We need to think about if the value is between -1 and 1. In the previous examples, I already found out that the arc sine is -π/3. So this answer is really -π/3, but I still need to take the sine of that angle. We actually already found that answer as well. So sine of -π/3 is really -√3/2. Going the other way, if we had sine in the interior, well, we know that sine of -π/3 is -√3/2 from the previous example, but now we have to take the arc sine of -√3/2. And we already did that, but just to reiterate the point about restrictions, is if you're dealing with arc sine, it has to be in quadrants 1 and 4. So where are the y values, -√3/2? right here and right here. This is the only angle that's in quadrant 1 or 4. So my answer could be 5 pi over 3, but as we've talked about, that is not in the restrictions, which is why the answer is negative pi over 3. So some of you might notice that in these two compositions, that if you have sine and the inverse right next to each other, the angle here, or the ratio here, ended up being your answer. So it seems like these might have just kind of crossed out. And in this example, the arc sine of the sine, these are inverses, and the answer of this angle is the same at the end. So it seems like we could just cross these out. The reason I mention this so early is it's really tempting for students want to just say, oh, I'm going to cross this out, I'm going to cross this out. The only time that the angle ends up being the same as the beginning, or the ratio ends up being the same as the beginning, is when your restrictions are intact. So in these examples, this ratio and this angle happen to be within my restrictions that work, which is why it seems like the sine and arc sine just cross out. So you need to be careful of your restrictions, and that will become more apparent as we keep going through more examples. So strategies for evaluating the composition. You want to always evaluate the most inside function first. And the first thing you always want to try to do is use the unit circle, and that is what this video is about. But as a second resort, you could always draw a triangle if you need to, or use the calculator if you need to, and both of these are going to be in the next video. But for now, let's focus on the unit circle. And this is here for you to read at your own time. Now, using your unit circle plate or this, let's go through some of these examples. Starting with the most inside function, the cosine of 3 pi over 4. 3 pi over 4 is right here. The cosine, or the x value, is negative root 2 over 2. Notice that cosine has no restrictions, but if we're dealing with arc cosine, that has a restriction between 0 and pi, or quadrants 1 and 2. So we're asking ourselves, where is the x value? What angles is the x value? Negative root 2 over 2. Well, here and also here. Which one of these is in the restriction for arc cosine? Well, we're back to the original angle we started with, 3 pi over 4. This is another example that 3 pi over 4 happened to be within the restrictions already, so it seems like these just cross out, but please be careful about that. I think in this next example you'll see what I mean. If we wanted to find the sine of 3 pi over 4, same angle, the sine, or the y value, is positive root 2 over 2, but now we have to take the arc sine of this angle. If I think about what angles the y value is root 2 over 2, that is here and here. This time, which one of these two is in the restrictions for arc sine? Well, arc sine is restricted in quadrants 1 and 4. This is the angle that is in the correct quadrant, not this one anymore. So my final answer is not 3 pi over 4. My final answer is pi over 4, because this works with the restrictions. Next example, tangent of negative pi over 6. Some of you might look at negative pi over 6 and say, I know that is going down from the x-axis, so you know that it lands here. But if you are confused by that, you could think about coterminal angles, meaning if you took negative pi over 6 and added 2 pi or 12 pi over 6, you would land at 11 pi over 6, which is this position here. So what we want to do is find the tangent at negative pi over 6. Remember, we have root 3 over 3 here, 1 here, and root 3 here for our tangent ratios. So 11 pi over 6 is a 30-based angle. So my tangent would not be positive root 3 over 3, but in the fourth quadrant would be negative root 3 over 3. And now we want to find the arc tangent of negative root 3 over 3. Well, what quadrants is tangent negative? It is negative in quadrants 2 and 4. So I'm looking at either, let's see, negative root 3 over 3 30-based angle. I'm looking at either this answer or this answer based on my unit circle plate. But this is the only one that is in the restrictions for tangent, which again is between quadrants 1 and 4. So I think this is another example where my answer ends up being what originally was there, because positive 11 pi over 6, remember, is really the same thing as negative pi over 6. So this is another one where the restrictions were correct at the beginning, so it looks like these just cross out. The next example, cosine of 3 pi over 4. So let me find 3 pi over 4 right here. Cosine is, again, negative root 2 over 2 there, because that's where the x value is. Now I want to find the arc sine of this. Sine, or the y values, what angles is it negative root 2 over 2? Well, right here and right here. Which one of these, though, is in the restrictions for sine? Quadrants 1 and 4. Looks like 7 pi over 4 is the angle we're looking for, but remember, if you need that in the restrictions, this is equivalent to negative pi over 4. These two examples we actually just did, so let me cross that out and go to the next ones. If we want to find the tangent of 2 pi over 3, that's right here. That is a 60 base angle. So if this is positive root 3, this ratio is negative root 3. Arc cosine. Then I say arc cosine. I'm thinking x values. I scan my unit circle and notice that cosine, the x value is never negative root 3. So that gives me pause. So I look at my restrictions and I say cosine has to be between negative 1 and 1. If I calculate negative root 3, that is really negative 1.732, which is not in the restrictions, which means that this example does not exist because you can find the first part, but you cannot find the arc cosine because of the restrictions. Cotangent. So we are looking for the interior first, cotangent of negative 5 pi over 6. If you're having trouble just looking at this and knowing where this angle is, remember you can think coterminal angles. You can add 2 pi or 12 pi over 6, which is 7 pi over 6. That helps me know at least where I'm looking here. We want to know what the cotangent is at negative 5 pi over 6. Well, these two go together. The ratio for tangent's root 3 over 3, which would mean that the ratio for cotangent would be the reciprocal, or root 3, interestingly enough. So here the tangent is root 3 over 3, but we're looking for cotangent, and cotangent is really the reciprocal of root 3. Because it's in the third quadrant, it is a positive ratio. So now we want to find the arctangent of root 3. And the arctangent of root 3 is either in two locations. It is either root 3 at 60 degrees or at 240 degrees. Which one of these is in the restriction for tangent? Well, tangent is restricted quadrants 1 and 4. So I know that the angle that is correct is pi over 6. These last three examples I would like you to try on your own. When you come back, I am going to show all the work, and you can check with me. Please pause now. All right, guys, so this first example, I said where is the x value negative 1/2 at 2 pi over 3 and 4 pi over 3. However, our cosine is restricted to quadrants 1 and 2, so I said 2 pi over 3 was the interior answer, so then the y value at 2 pi over 3 is root 3 over 2. The second example, where is the y value, at what angle is the y value 1 at pi over 2? What is the secant of pi over 2? Well, the cosine of pi over 2 is 0, so the secant is the reciprocal 1 over 0, or undefined. The third example, where are the x values, negative root 2 over 2, 3 pi over 4 and 5 pi over 4? But cosine is restricted to quadrant 2. So what is the cotangent of 3 pi over 4? It's -1.